is exactly how it's reported in all textbooks. But that's surcharge pressure times a constant. And then we get an extra term here. These terms, NC, NQ, N gamma, they are a function of phi. When phi equals 0, NC has a value of 2 plus pi, i.e. 5.14. When phi is 0, NQ has a value of 1. And when phi is 0, N gamma has a value of 0. But as phi starts to increase, the values of those constants gets bigger. And so we can find those by looking them up in tables. That's what most engineers do. So what you get are these, what we call bearing capacity factors. And we look these bearing capacity factors up in tables, such as this one here. I've reproduced this from Eurocode 7. So these are the values which we use in the UK when we're designing to Eurocode 7. The reason why it says Annex D is because the annexes of a Eurocode are your nationally specified values for things. So there's the overall philosophy throughout Europe, and then there's national basis for picking your parameters. So these is what we use, and you can see, although it doesn't go to 0, when phi is 12 degrees, N gamma is already equal to 1, and when you go all the way down there, it goes down to 0 for very low phi. Okay. What we've done in this lecture, and it's really time to start to summarise that, but do give me a chance to give you a proper summary. Well, the first one, we've already know that. So here we are. Our bearing capacity analysis, there's a family of analyses which follow the same basic principles. For teaching purposes, because I'm not a believer in asking people to produce complex proofs under exam conditions, what I like people to understand is the fundamental principles upon which an analysis is based. So what I did was pick the simplest of the family of analyses, even to the point where I used slightly the wrong mechanism in order to simplify the geometry. But what we saw was we had to make a number of assumptions, and the important ones being that the soil is rigid plastic, that the soil is uniform in the zone of the mechanism, and that there is a failure mechanism that forms when we load the foundation to failure. And then for that mechanism, we looked at its equilibrium at the point of failure, what we're calling a limit equilibrium or limiting equilibrium analysis. So that's what we're doing, and when we do that, we find we get a bearing capacity equation which is general for all strip footings, and it has the form here. We found it was equal to CNC plus QNQ, where NC was 2 pi and NQ was equal to 1. I've now said that actually for cohesive soil it should be CNC plus QNQ, where NC is equal to 5.14 and NQ is equal to 1. But when we go on to granular soils, or drained soils, where we have a full Moore Coulomb strength equation looking like this, that's the full format. And what we're saying is, I haven't put it on the bottom of the slide there, is those values NC, NQ, N gamma are things that geotechnical engineers look up in tables. And nowadays we use the table which is in the annex, the UK annex to Eurocode 7. And that table I've put in your notes. It's also on the data sheet for the exam paper. So I have a philosophy which is things that I can't remember, I don't expect you to remember. So if you want to, it's a bit early yet, but if you want to look at end of year or end of semester exam papers, you'll find I have a data sheet on the back, about 5 sheets containing useful formulae and lookup tables to support geotechnical design. Okay, I've finished slightly early, which is uncharacteristic of me, but let's celebrate it by ending now.